Solving quadratic equations. The objective of this video is to solve a quadratic equation. So first we want to recall how to factor an expression from lesson 1. Remember, we can use the sum and product method in this case, which means to multiply first and last term, which in this case would just be 1 times 14, giving me 14. Then we want to list factors of 14. So we have 1 times 14, 2 times 7. And then we want to figure out which factors multiply to give me negative 14 but add up to give me positive 5. So if I have negative 2 and positive 7, these would be my two factors. So I can split up my middle term as factors of negative 2 and 5. So negative 2 x squared plus 7x squared minus 14. And then I can factor by grouping. So I'm left with an x squared minus 2 and then 7, so x squared minus 2. This checks out because my two parentheses are the same, and I am left over with an x squared positive 7. So now we want to actually solve the equation. So that means we might have to use factoring in order to break down the expression into something smaller. And then we want to use the zero product property, which means that whenever I am multiplying things and they equal 0, at least one of the factors has to be 0. So I can set each factor equal to 0 and solve those mini equations. So in this case, we are going to solve by factoring. In order to factor, we have to make sure that everything is on one side of the equal sign. So I'm just going to rewrite my equation by moving my 22x and my 8 over to the left. So I have 21x squared minus 22x minus 8 equal to 0. And now I want to factor using the sum product method. So I'm going to identify my two numbers. So I listed the factors of negative 168, and my two magic numbers will be 6 and negative 28. So I'll rewrite my middle term with those numbers. And now I can factor by grouping. Once I've factored my expression, now I can set each factor equal to 0 and solve these two small equations. Sometimes you can end up with a fraction, whole number, complex number. Well, no complex numbers when you're factoring. So now you try to do the problem on the right. Pause your video, see if you can do it on your own, then press play to see if your answer is correct. Pause your video now. First, you want to identify that there is a GCF in this one and take that out first. So the GCF is 7. So that leaves me with x squared minus 14x plus 48. So now I will list factors of 48 to find my magic numbers. So I know the two magic numbers will be negative 6, negative 8. So I'll rewrite my middle term as factors of those two numbers. And now I can factor by grouping. Once I've factored out my expression, now I can set each factor equal to 0 and solve. So my answer is x equals 6 and 8. Sometimes we do not need to factor in order to solve one of these equations because we can use the square root. So in this case, I'm going to isolate x squared by removing the 5 from both sides. So I'm left with 3x squared equals 6. Divide by 3. So x squared is equal to 2. And then I'm going to take the square root of both sides. This leaves me x by itself. Remember, whenever you take the square root of a number, we're looking at the plus and minus of it. Square root of 2 can't be simplified, so we're just leaving that as a radical. So our answer is x equal to plus or minus radical 2. So again, we can find the answers by isolating x squared. So I will add 3 to both sides, leaving me with 4x squared, 196. Then I'll divide both sides by 4. So x squared is equal to 49. Again, we want to take the square root. So in this case, we're left with x plus or minus square root of 49 is 7. So in this case, I do get a nice whole number. Now, sometimes when we're taking the square root of an equation, we end up with some complex numbers. So here I'm going to do the same thing. I'm going to isolate to b squared by adding 10 to both sides. So I'm left with 8b squared equals negative 99. And then I'm going to divide both sides by 8. Can't actually simplify that, so I'm just left with negative 99 over 8. Now that I have to take the square root of this number, because it's a negative, I am going to end up with some imaginary numbers. So I am going to end up with v equal to plus or minus whatever the square root of 99 over 8 is, I do need to rationalize this, so we're going to look at how to simplify the square root of 99 over 8. Square root of 99 over 8 is the same thing as having the square root of 99 over the square root of 8, and we cannot have any radicals in the denominator, so we have to rationalize this by multiplying the top and bottom by negative 8. So when we do this, we end up with the top number being 792 and the bottom number being 64, which is a perfect square, so the square root of 64 is 8. So now that we do not have a radical in the bottom, we just have to simplify the square root of 792. I can break up 792 as factors of 4, 9, and 22. So now simplifying further, square root of 4 is 2, square root of 9 is 3, square root of 22 can't be simplified, and it's 8. 2 times 3 is 6. And I can simplify 6 over 8. So now I can go back, and this 4 actually is plus or minus 3/4 I square root of 22. Another method to solving a quadratic equation is to use a quadratic formula. Now this one is a longer way in some cases, which is why factoring or solving by taking the square root is easier. However, the quadratic formula will always work. So we are going to see an example of this one. First, you want to make sure it's in standard form, meaning everything is to the left. So I will rewrite it with everything on the left-hand side. I will identify my A, B, and C. And then I'm going to fill in everything into my quadratic formula. So x is equal to negative 6 plus or minus square root of 6 squared minus 4ac over 2a. And now I'm just going to simplify a little this giant fraction. Next, I want to simplify what's inside my radical, which I notice is going to give me a negative number, so I will have an imaginary number in here. And now I am just going to simplify my radical and then my fraction. So I'm breaking up my negative 272 into factors of 16 and 17, and I because it was negative. And now I'm just going to simplify my fraction. Don't forget to reduce fractions if necessary. So my answer is x is equal to negative 3 plus 4i square root of 17 over 11. and negative 3 minus 4i square root of 17 over 11. So another method to solving a quadratic equation is to complete the square, which makes something that was not factorable factorable. So step 1 is to rearrange by moving all the constants to one side. So 42 is a constant, so I will move that to the right by adding 42. So I'm left with 5n squared plus 10n equals 40. Step 2 is to make my first term. Well, note, before I can use step 2, I want to make sure that my first term is 1, and I can do that by dividing. So I'm going to divide the entire equation by 5 in this case to make it 1. So n squared plus 2n equals 8. And now I will do step 2, where I take the middle term, which is 2. In this case, I will need to divide by 2 and take the square. So 2 divided by 2 is 1. 1 squared is just 1. So I will add 1 to both sides. And now this right-hand side is very factorable. This becomes n plus 1 squared. And now I can solve by taking the square root. So n plus 1 equals plus or minus 3. I'll subtract 1 on both sides. So n is equal to negative 1 plus 3. Well, 3 minus 1 is 2, and the negative 3 minus 1 is negative 4. Now you try. Factor the expression completely. It is up to you to identify which would be the best way for you to factor this expression using any of the methods we have gone over in this video. Pause your video, see if you can solve this correctly, and then press play to see if your answer is correct. Pause your video now. So in this case, I could have chosen to solve by factoring, using the quadratic formula, or completing the square. If a question is asking you to factor an expression completely or solve, you can use any method you want, unless it is specifically specified to use to solve by factoring, or to solve using the quadratic formula, or by completing the square. In this case, I did not solve by taking the square root because I had x squared and x. If you look back in the video where we solved by taking the square root, we did not have expressions or terms with an x squared and an x in both of the terms, because that would make it a little difficult, meaning you would need to factor at some point before you can move on. So either case would have been the correct answer, as long as your answers ended up being 14 and negative 4.